All right, welcome to Lab 8 of AZ-800, implementing hybrid networking infrastructure. Basically what we're going to do is now take a look at how to do things in hybrid environments instead of just Windows Server. So I'm already logged in to the admin server, and I'm running Edge here, logged into my Azure portal with the credentials given by the lab provider. And we first have to create something using Cloud Shell. It's a bit bigger. I'm going to use PowerShell. Let's use storage. All right, here we are. We're supposed to upload the scripts. There are under all files in my lab provider. This was lab 8. We need to upload both of them. Cool, that's done. Then we're supposed to run the template. Let's first create a resource group for it. So let's say we're going to need this later, right? So let's put in RG name equals AZ-800 lab 0801 RG. And then location equals East US. Okay, so now we can do a new AZ resource group with the name, RG name, and then the location. Right, and now we can deploy the template as well. Oh, I put a hyphen at the end of that. Well, let's just create a new one. Thankfully, these don't cost anything. All right, so that created 3 VMs. Next up, we're going to run a quick script that will go and add the network watcher agent to each of those VMs. Again, I'm just going to use it directly from the instructions. All right, so then let's open another tab. And then let's do some networking. Networks. No. Should have a network here, VNet. Yeah, that's better, VNet. We have 3 networks created. And let's first go to VNet 0. And now what we're going to do is we're going to peer these 2 VNets. I think it's here. Cool, let's add a peering. So the remote peering link name is 120. And the network is 1. And then we allow traffic to access us, yeah. Traffic forwarded, and network route server not. And the local network link is the other way around. And here it's the same. These two. And that's done. Now let's peer network 2 as well with 0. So again, the remote one is 2 to 0. And the remote network is 2. And again, we have the same allows. And the local peering is 0 to 2. Allows. And then add that one. So now I've peered VNet 0 both to VNets 1 and 2. And this is so-called hub and spoke model, where VNet 0 is the hub. And now we specifically haven't peered VNet 2 with VNet 1. So let's see if we can do traffic between them. And for that, we can use Network Watcher. And we want connection troubleshoot. And then we want the source to be a virtual machine, VM0. And then we want the destination to be something like 10.81.04. And let's say TCP and 3389. So we're kind of trying to log in to that machine. And we only need a connectivity test. And connectivity is reachable. So this is between 0 and 1 now. That's good. Let's try the same thing from 1. So we say EM1. Then the target should be 82. 82. Like IPv4, it's a bit faster. And that is done, unreachable from 1 to 2, right? Remember, this is hub and spokes, these are 2 spokes. And then we can also check that 2 is actually available from 0. Just on that one. And that one is reachable. So we've just verified that the hub and spoke network is working as intended, so that there are connections between 0 and 1 and 0 and 2, but specifically not between 1 and 2. So if we want something like that to happen, we need to add a router into the hub network that then can control what kind of traffic should flow. So let's do that. We have a virtual machine in there. That's the 0. And all we need to do here is we need to specifically set up IP forwarding. We go to the network card, and then here under IP configurations there is this enable IP forwarding part, right? So now it can act, if this is on, it can act as a router. Apply that. So let's go back to our virtual machine. Then we could run a command. Go run PowerShell script. The command is going to install remote access. All right, that ran successfully. Good. Then we have another script where we're adding the routing feature and everything else that is necessary. All right, so now that finished, and everything seems to have worked correctly. So let's look at some route tables in Azure. This is how we direct traffic between, for example, VNets. So we can create one. East US, the name is going to be route table 1, 2. And we don't want any route propagation in our case. All right, that's done. So let's go and take a look at it. So here is our route table. Now under settings, we have routes. So now we can add a route here. We're going to add a route for traffic that goes from VNet 1 to VNet 2. So let's name it accordingly. The destination type is IP addresses. The CIDR range is 182.0.0. Next hop is virtual appliance. And it's the IP address of VM0. So I'm just going to copy paste it in. There we go. So that means traffic that goes to VNet 2 actually goes to VNet 0 and our virtual machine therein. Then we need to associate this route with subnets. So this is route is only going to be considered when we have a particular associated with a particular subnet. So this one was the 1 to 2. So we need to put it into VNet 1. I think there's only one subnet there, yeah. So I'll put it there. Cool. So now let's go back and create another route table. This time, of course, for routes from 2 to 1, right? So this is the same as previously. And similarly, we're going to add a route here. Just kind of the mirror image, really. So if you want to go to VNet 1, you also go to VM0. And then we associate this with VNet 2 and the only subnet they're in. Cool. So now if you go back to the network watcher and then the connection troubleshoot here. Now if we want traffic from 1 to VNet 2, $33.89 for example. Let's just do the connectivity check. We do have connectivity. We could have looked at the intermediate hops and then seen that it's actually going via 1080.04, which was virtual machine 0. And then this might add latency. So when we're peering two networks, there is no extra routing involved. So the connections are direct. But by adding routing, we're at least theoretically adding some possible latency to the traffic. All right, so next, let's look at DNS. So DNS in Azure does not work via, not necessarily work via Windows Server, but rather it is a service in Azure itself. So like if you have, we all have DNS in our VNets, but there are no actual DNS servers running in our VNets, right? We would see that. So the implementation is part of the virtualization layer, and it uses the Azure DNS service. So we can control that, right? So here we're going to create a private DNS zone. A private DNS zone means that it's only going to be available in our VNet, basically, or VNets. So they're not available in the on the internet. The other option would be to create a public DNS zone, and then that's meant to be distributed on the internet for your public domain names. All right, here we go. So under settings, no, under DNS management, it's changed. Under DNS management, we have virtual network links. So this decides where the records that are in this private DNS zone are viewable from. So we need to add, this is per VNet, so we need to add each VNet that we want to use. So let's add VNet 0. And we can enable auto registration. So any virtual machine that is connected will automatically publish its record here. It's done. Another one for VNet 1. Copy this and then change 0 to 1. There we go. And then the same for VNet 2. So now all of these, in a minute, all of these should be registered. So then if we take a look at our private zone. You can see we have 3 record sets here. And you can see that the VM0 from VNet0 and VM1 have already auto-registered themselves. And now that the last VNet2 has also been linked, pretty soon we're going to have a record for virtual machine 2 over here as well. Okay, we can test this again using Network Watcher, connection troubleshoot. Let's say we want to go from 2 to let's say virtual machine 0, right? That should be the name, and then let's say we want to use 3389 for that. So this now indirectly tests for the DNS resolution as well. And it works. So it did find out the right IP address for this DNS name. Good. So like previously mentioned, the other option is to use public DNS. These are published to the internet. So we can create a public one. And then we're supposed to use a domain name that is currently not in use. So I could say know that that one is not in use. It's done. Great. Here's our public DNS zone. Now we could add a record set here, something like www being 1.2.3.4, right? So if this would be our web server. Okay, and then this is done. So now, if we go outside of Azure into our virtual machine here, admin1, and then we open PowerShell, and we should be able to find this DNS record. So it was www.fairlane.net. Now, because this domain doesn't really exist, it won't be found like this. But if we query it directly from the Azure DNS server, then we should be able to get a result for it. So it's ns1-03 .azure-dns.com. There we go, 1, 2, 3, 4. So it seems to be working. That's everything we got for you in this lab. Thanks a lot for watching. In case you followed along, then please delete the resource group to make sure that there are no further costs related to this lab. Thanks again, and see you in the next lab. Till then.